6.7 lesson is finding the inverse of relations and functions. To start off with, we're going to be taking a look at different coordinates or t-charts and how to find the inverse of them. So for the first problem, notice this is our t-chart, this is our list of x values, this is our list of y values. So how we find the inverse is we're just switching the x and y values. So if they give you coordinates, it's going to be very easy that this x column is now going to be our y column, and then this y column is now going to be our x column. And then this will be our inverse, our answer. Okay, and the inverse, if we go back to the definition, is just the reflection across the line y equals x. So if we have this t-chart, then this diagonal line right here is the line y equals x. So we're trying to figure out what our new coordinates are that reflect across this diagonal line. Okay, now the second problem, if these are our new coordinates, to find the inverse, again, we just switch our x and y values. So you can do them individually, coordinate by coordinate, or just this x column is now our y column, and then this y column is now our x column. So this would be our inverse of our coordinates. Now let's take a look at if instead of giving us coordinates, they now give us an equation and they want us to find the inverse. So if they give us our equation, and we have y equals x squared minus 1, then we do the same idea. We're switching our x and our y. So now we would have x equals y squared minus 1. Notice we're not changing anything, we just switch the x and the y. And so then we have to get this new y now by itself, though, is key. So then we add the 1 on both sides. These cancel out, so these are not like terms, so we get x plus 1 equals y squared. And then we still need to get this y by itself, so to undo to the second power, we're going to square root both sides. When we square root both sides, we need that plus or minus sign, and then the square and our square root cancel out, so we're going to have y equals plus or minus the square root of x plus 1. So that would be our inverse. So this is our original function, and this would be our inverse. For this next one, we have y equals 2x plus 8. So again, we want to find the inverse, so we're going to switch the x and y. We keep everything else the same. So our equation would be x equals 2y plus 8. So now we have to get this new y by itself. So we're going to subtract 8 on both sides. Our 8's cancel out. So these are not like terms, so we just write them next to each other. So we have x minus 8 equals 2y. We have to get this y by itself, so now we divide by 2. So we get y equals x minus 8 divided by 2. Or you can divide both of these terms by 2 and get y equals 1/2 x minus 4. Now we're going to take a look at the graphs of a function and its inverse. And notice again the inverse, we're just finding the reflection across this line y equals x, so that diagonal. So our function for this first example is going to be y equals x squared minus 1. So we want to go ahead and switch the x and the y. And notice we already did that up here in number 3, so we don't need to do that again. We'll just take a look up here. This is the original function. This is our new function, so we want to now graph both of those and see what a function and its inverse looks like. So we're going to go to y equals. We clear out the equations that I have in there. We have x squared minus 1, and then our second graph, we're going to have plus or minus, and then our square root of x plus 1. Now the graphing calculator, I do not know how to do the plus or minus sign, but I'm going to show you how to get that plus or minus in terms of your graph. So go ahead and just graph it. And notice the first one's going to be that parabola. And then the second one, we just typed in the positive square root of x plus 1. So notice it gave us this positive curve. We also need that negative to take into account. So that's just going to reflect it over and give us the bottom half of this parabola. So this parabola, when it was reflected across the line y equals x, and instead of going up and down, it ended up moving left and right. Okay, so then our graph, you would just need to sketch it. This is our first graph, and then our second one, we get that sideways parabola when we do the positive and the negative. Okay, so let's take a look at the second problem. We have y equals 2x plus 8. Again, this was the second one that we did up here, so we've already solved for them. So we have this original equation, and then you can type in either one for the inverse, whichever is going to be easiest for you. So maybe let's do the second one. So we're going to go click on the y equals, clear out the equations that we have in there. So our first one was 2x plus 8. And then our second equation is a half x minus 4. And how we do that half, just put it in parentheses. 1 divided by 2 parentheses x, and then minus 4. We're going to click graph. So then we have these two lines. The first one is going up here, and then the second one, the inverse, is going down here. So notice each point is reflected across that line, y equals x. So then we just make a sketch of it. Okay. Key on inverse, do not overthink it. It's just the reflection across the line y equals x. So you're literally in coordinates just flipping the x and y values, and then in an equation you're switching the x and y values and then solving for your new y